Hi, everybody. Good morning. Chem 103. So, not too much to do today. I wanted to once again emphasize the biodiesel project, and hopefully that is all going well. So, we're going to talk about that in the second part of the video. First, I want to do a couple more examples from this sheet. As I discussed last time, we did the first one, and I'm sure you can go through and do a couple of them, but some of the weird ones I just wanted to go through just to make sure you're on the right track for those of you who are working on it. So let's take a look at number 3 and compare it with number 1. So in number 1, we reacted carbohydrate glucose with oxygen O2 to produce water and carbon dioxide. And that is oxygen in its elemental state is generally O2. It's two oxygen atoms bound together. But in number 3, we have something different happening because it's way up in the stratosphere where there's lots of energy. And so instead of having oxygen molecules, O2, we have high energy oxygen atoms. So for that one, we're going to start with nitrous oxide. Now, the formula isn't given here because you should have found that formula earlier when you did the other greenhouse gas things, because nitrous oxide is a greenhouse gas. So it's N2O, reacts with high energy oxygen atoms, O, to produce nitric oxide. And then you can balance that like this. So if you do this as O2, it becomes a lot more complicated to try to balance, and that's not the reaction that's happening up in the stratosphere. So little things like that, just watch that when you're going through these. Number 4, carbon dioxide dissolved in water to yield carbonic acid. Carbonic acid partially dissociates to produce hydrogen carbonate and hydrogen. This is also known as bicarbonate, like in the sodium bicarbonate that you used to clean up the water. So for this one, we actually have 2 reactions. Carbon dioxide dissolves in water to yield carbonic acid. That's one. And then carbonic acid dissociates to produce this and this. That's another reaction. So you can list those as like first one, second one, or you can just use 2 arrows. So you can go like CO2 plus water yields carbonic acid, and then that goes on to react to produce the bicarbonate anion and the hydrogen ion. So that, let me move that out of the way. That works as well. Okay. Number 5 is pretty straightforward. Number 6, well, actually for 5 and 6, remember that when oxygen is being reacted as a chemical, except for that one weird exception where it specifically said oxygen atoms, we're always going to use O2 as oxygen, not just O. There are several elements that always exist as a dimer, as a double like that. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen when they're by themselves. All right, number 7. The weird thing here is that this nitrous oxide gets photolyzed, which means reacts with light. High energy photons are light. So those may not really be in the balanced chemical equation because light is not matter. So when we're talking about this one, there's a couple ways to do this. So you can just write it like this. Nitrous oxide produces nitric oxide and a nitrogen atom, and just leave the light out completely. Sometimes how these are written is like something is drawn over like a little lightning symbol with an arrow is drawn over the arrow to show that light is being added in. And then another way that that's shown is H and then the Greek letter nu. H nu is the photoelectric equation. That's the energy of a photon. So sometimes that's another just way of saying light. But neither of those things are matter. They don't have mass because light is just energy, pure energy. So they don't affect the balancing at all. The balancing just comes from the atoms. All right. I think the rest of these are pretty straightforward, and I think you can figure them out. So hopefully it goes well. Don't forget, besides the balancing, you also want to identify the the process as a source or a sink for the greenhouse gas. And you want to say whether it's human-made, anthropogenic, or natural. And then finally, you'll have that equation that we just worked on. So hopefully you don't have too much trouble with that activity. Okay, let's take a look at the biodiesel project for the last time here. Make it a little bigger here. All right. So from last week, I haven't made it through all the grading yet, but assuming things went okay, you had turned in your calculations. This week, you need to put them all together in this document. So you should answer all of these questions throughout the entire thing, with the exception of the ones we talked about before. You don't need to calculate the theoretical mass of glycerol, the mass of methanol. So these second two parts on number 2, you don't have to do. You just have to calculate the theoretical mass of biodiesel, which we did together. And then you've got the percent yield, and then some research type questions. And then looking at the heating values, comparing to the table. And remember, number 1 is a very short, simple question. Did you produce biodiesel? But it should have a pretty big involved answer. Use all of the experimental evidence you collected and analyzed to support your claim. So everything that you did, all the testing, everything as part of that biodiesel analysis, those results should be dealt with in number 1. And if you have results that run counter to the question, so if you have evidence that you did not produce biodiesel, or maybe that it was not pure, maybe from the wash test or the methanol test, you saw that it's not in fact pure and there's some other stuff in there, make sure to include those as well. And so then once all this stuff is in, I will go through it and grade it, and you'll have that. And then next week, we will start on our final project, which is going to kind of take up the rest of the semester, looking at scientific papers and how to analyze them. So that's all for me this morning. As usual, let me know if you have any questions or concerns. Those of you who turned in some late work, if you let me know, I'll be going through those this week. So hopefully we'll get all caught up soon. If you still have late work to turn in, make sure to get that in. And then finally, the next week in lab is our makeup week. So if you have any labs you need to make up, let me know now, hopefully by the end of the week, or at least maybe Monday on the latest, so I can make sure to get materials together. And then I'll plan on you coming in at lab time on Wednesday to finish those up. So hopefully I will see some of you there. I know several of you have missed labs, so you let me know if you need to make those up. And the rest, those of you who don't have any labs to make up, I won't see you until after Thanksgiving. So have a great Thanksgiving. Oh, happy Veterans Day, by the way, to those of you who are veterans. And I will see you after Thanksgiving. Well, that's not true. I'll be online next week talking about the project, but I'll see you in person after Thanksgiving. So thanks. Bye, everybody.